Well, good morning, everybody. Just a quick note, this will be my last forecast video of 2023. I'm going to take a little time off between Christmas and New Year's. Pretty excited heading out to the Peach Bowl. My daughter actually is going to play in the band down there, so I'm excited that she gets to do that. So we're going to travel with her and have a great time doing that. But before we go, I do need to get out quite a bit of information here that I think is important just to kind of wrap up this year and to think about what 2024 is going to bring. So you've been staring at a map that shows our latest drought monitor. This is the one that was released yesterday morning. And I just want to give you some stats on this, and I'd like to do kind of what I did yesterday, which is a comparison to last year. So as you look at it, we have about 50% of the land area in the lower 48 in some form of drought. Now, I just want to be clear, when I say that, I include the abnormally dry category. If you want to talk about the drought categories themselves, it's about a third of the country that's in some form of drought. Now, compared to a year ago, we had 74% of the lower 48 in some form of drought, and that was because there was much more extensive drought throughout the West. And just to be consistent here, we had about 50% of the land area in those drought categories. So if you include abnormally dry, 74%. If you include only the drought categories, 50%. So we've made a significant reduction, but there are still places that, while drought has been reduced in some areas, it has gotten much worse in other areas. And I want to show you just a fun tool that I hope maybe you play around with over the next couple of weeks. So let's go to this next tab. It's just weather.gov. And when you get here, one of the things I like about it is the map is actually hyperlinked. So you can pick any spot you want. I don't know, let's go down to this part of Kansas. I just randomly picked it. When you get down there, I'm at the Springfield, Missouri National Weather Forecast Office. And what I want you to do here is I want you to go over to this link right here. It's on every one of these pages, Climate and Past Weather, and just click on it. When you click on it, you'll be brought to a tab. It doesn't matter where you click in the country, it'll look something like this. And I want you to play around with this now data. So I'm just looking at here, and you can look at the locations that are provided, or you could actually click on a map. And you can see there's a blend of Missouri and of Kansas stations in this particular weather forecasting office headquarters. So I don't know, let's just go back up to the top and pick the Springfield, Missouri area. Now what I'm doing here is I'm going to click on accumulation graphs, and when I do that, I'm going to be looking at the variable of precipitation, and then I can adjust the time. So I don't know, let's just go back to 2020. Let's start this on 2020, and I don't want to reset. I actually want to see the cumulative effect of precipitation since January 1st, 2020 until now. And when you click on it, this is what you end up getting. So it's a really kind of interesting graph, and you can hover over it and see what the comparison looks like. Now, the smoother line would be the average, and the line on top in this case would be the what's actually happened. So interestingly enough, over that long time period, 2020 till now, Springfield, Missouri area is, about 5 inches above historical average. Now, you can imagine this doesn't look like that everywhere. In fact, if I go back and I pick out some spot here, let's go back to Iowa, and I do the same thing, you're going to see much different scenario here. So it's set on Des Moines. I don't know. I wonder if Mason City. Okay, let's go to Mason City here, and I'm going to click on accumulation graphs. I'm going to do the same thing. Let's take that back to 2020. No reset. Click go. And now you see a much different scenario. I mean, look at this. Mason City. Whoops, sorry about that. Average would be 126 inches that's 4 years. Normal's 144. What they've gotten is 126. So, we're off here by 18 inches of total rainfall. And there are some places across Iowa, across parts of the plain, not just Iowa, that are not just off 20 inches in rain, but are off 30 and 40 inches in some places. So I just find this to be an instructive way to look at that cumulative effect. And the only reason why I'm worried about that is because we're going into another winter similarly to what we did last year. Now, there are some differences. This is what the root zone soil moisture map looked like last December 22nd. That's 2022. This is the newest one. That's the previous. Now, a couple things to take note of. Look at the Eastern Corn Belt in both cases. Look at the difference, though, in parts of the Northern Plains. This is last year versus this year. And I do notice one thing. Iowa has been it the whole time. And that's why I kind of chose that area just as a place to kind of examine a few moments ago. Now, this is the current map again. And, of course, one of our biggest concerns is just the expansiveness of this dryness throughout the Mississippi Valley, including the Ohio River Valley, the Missouri River Valley, and all of the tributaries that feed into those. Mississippi River this morning, was 7.74 feet below low stage. A year ago at this time, it was 10 feet above low stage. It did bottom back out right in here, about 2 feet below low stage in early January, but that's before it made a pretty massive recovery into March and April, when we actually had some flooding on the Mississippi River. So don't forget, last, March, we actually had to shut down part of the Mississippi River in around the Quad Cities because of Quad Cities to Dubuque because of flooding. And that was mainly because the snows on the headwaters of the Mississippi. So let's talk about the difference between last year and this year so far in snow. So I made this map to reflect from the September 30th of 2022 to 12/22/2022. So this is what the snowfall looked like a year ago up to this point in the winter. And here we are this year. Now, we know it's been an incredibly mild year. We've had deep cold air in Alaska. We've had a big central Canadian ridge. We've kind of ruined the pattern for what we had a year ago, which is a lot of southwest flow. And we're waiting to see if this pattern is going to shift around and give us a different look. So just thinking about that, I want to show you one other thing. This is what happened in the kind of week following, actually not the week, but the 2 weeks following Christmas. Remember, we had the first of a series of massive low pressure systems that just slammed into the west and finished with big snows right in through here. So what you're looking at is December 24th last year to January 10th of this year, and it was one of the wettest stretches of days. And this is what began to break that drought in California. They got hit again in March, which helped kind of finish the drought problems. Where are we kind of, one other thing. Again, I picked up on last year. This is also a big difference from last year. December 21 through the end of the year, we had, remember, a pretty sizable cold air outbreak that hammered most of the country with really, really cold air around and after Christmas. So this was kind of the setup, bringing in all the cold air to help deliver that big system that follows. Now I say, where are we comparatively? Well, most of our next 10 days, we don't shake the overall mild pattern. Now, this does not mean that we won't get shots of cooler air, but we're still in this narrative of waiting for something to change. And I have some evidence of some change, but I'm very worried that maybe I'm not giving the persistence in the forecast enough credit, not only here, but in South America, which is where we're going to finish this video. But just take a look. Over the next 10 days, where's our coldest air? It's the Bering Sea. It's part of Alaska. It's this side of Russia. It's in Greenland, where the polar vortex currently resides, which has been displaced and it is weakened. We are all watching it, wondering if there's going to be a connection to the tropospheric vortex, and that's yet to be determined. Anything we say about it at this point will be speculative. But the reality is, if you place a bunch of cold air here and here, it will not be in the middle part of North America. And this is a combination of events, beginning with the Pacific jet stream, ending with the Atlantic jet stream, and then the overall behavior in the Arctic, which is the building of pressure throughout the Arctic. So I think about all of that, and what it just makes me wonder is, when do we start to break away from this? And we're going to try to answer that question when we get to these slides right over here, okay? Okay, so what do we have? Over the last 72 hours, in fact, I just started recording this after 6 a.m. There we go, got the newest data. The flooding in parts of Southern California has been just bad. I'm sure you've seen it on some of the news. That low that's moved through here has just produced a tremendous amount of rainfall and a lot of local flooding in this area. That's going to be the low that we're going to watch slowly break its way out into the southern plains after delivering some moisture through here, and then get out into the plains. It's going to be a snowmaker on the back side of it. It's going to draw in a lot of warm and very wet conditions into this section of the country. The models have gone toward the European solution, slowing this down and taking it toward New England. And so we're going to have to get a good look at what that means going forward. But just as the sun was rising early this morning here on the East Coast, I wanted to take you back to yesterday, because a couple of things I just wanted to point out. There's the low we're talking about. Okay, here's just kind of the opening up of the Gulf of Mexico ahead of it. I did still see quite a bit of snow on the ground in parts of Saskatchewan, Manitoba, and parts of North Dakota here. But if you've probably kind of been paying attention, especially in the west, the fog throughout much of the Pacific Northwest, like in the Columbia Basin, part of the I-5 corridor, and then up here by Seattle, has been just truly spectacular. Just Google or get on Twitter and look up some of the Seattle fog pictures that have been here lately. They're just incredible. Well, last night, there's that low. Look at the just stream of moisture coming out of that side. So do you see the southwest pull right there, that southwest flow? Yeah, that's what we need. And that low, early this morning, is starting to make its way over into Arizona. So we have flood watches that continue for this area. There's dense fog advisories here, here, here. There's a winter weather watch that's out, winter weather advisories out for the Cascades. And we're going to see how this all translates into snow here in just a few moments. But the setup man behind it is right here. And this is that jet extension we talked about. It's still working its way across the open Pacific Ocean. And it's going to kick off a series of lows. I think I counted 4 of them. They're going to try to curl up right here just off of the Pacific Northwest coast. Now, why don't they really just barrel on through? Well, it's all about the position of this jet stream max here, and then the downstream ridging we keep getting in this area. The split flow, can you see? I mean, the split's really obvious here. There's the northern branch, there's the southern branch, and that split is what's problematic for the rest of the country really taking advantage of a big jet extension. But it's common that we don't. It's usually only the West Coast that sees the benefit of a true jet extension like this. So let's pick it up with the high-res models. Early this morning, we're going to watch rain throughout the day today move through parts of the Midwest. We're going to see a frontal boundary swipe through parts of the Pacific Northwest. That's number 1 of the 4 I'm going to tell you about. And then notice throughout the day today some locally very heavy rain moving through Arizona out of Southern California. Now that low, remember, has 3 components to it. There's the main wave here, and there's 2 short waves north of it. And that's what you see bringing the snow into this area. Now the latest high-res NAM wants to pull this system out, getting into Saturday, the risk of some storms down here to the south, rain out ahead of this by Saturday night, and then you're already watching the conversion over to snow on the backside. But the question is how much snow? We do know there will be snow here, but the models, as you've watched me tell you all week, have bounced around quite a bit. But that's through Saturday night. As we play this out into early Sunday morning, let's just park it right there. This is where we're going to be watching this system kind of slow down in its forward speed and possibly sit and spin over this area for a while before making it into New England. So we need to assess how much rainfall we're going to get out of this. So I'm going to go to my model comparison here just to show you the GFS on the left versus the European on the right. So we've already seen up till Sunday morning. As we work our way into Sunday evening, look at how much better agreement the models are in by Sunday evening compared to where they were earlier in this week. But of course, it's only 72 hours out. Now, as that all takes shape right here, we have system number 2 coming into the northwest. But remember, the jet extension, you can't see it, but the jet extension doesn't get all the way to the west coast. So these start to curl up right here into British Columbia. Now, as I look at it, the models throughout the day on Christmas, let's just walk through Christmas here. This is 6 a.m. getting into noon to 6 p.m. You can now start to see that both models have tried to increase the likelihood of getting some snow kind of in this corridor. Rain out ahead of it, very mild, and rainy out ahead of it, although I think the forecasts are too mild given the cloud cover and rain that's coming through for parts of the Midwest. But this is noon on Christmas, and this is Christmas evening. Now the concern is on the northern side of this, possibly Christmas afternoon, evening, and then overnight, is where we're going to get some ice. It's starting to show up in both models, and maybe a conversion over to some heavier snow. Look, it is well aligned right now in both models for midnight on Tuesday morning. Meanwhile, system number 2 is hitting the northwest. So as we watch this system curl up on Tuesday of next week, getting into Wednesday morning, Wednesday midday, and then Wednesday evening, there's system 3 for the northwest. Now what's happening while this system is kind of lashing a front across the western United States, what we see here is, well, I should say the west coast, just the coastal areas, is we see this little guy right here, which is a part of a jet max coming off the base of the trough that's sneaking in on the subtropical jet. Not cold, just fast. And what it's going to do is it's going to sweep through there and add to the lift all along the East Coast. So the question will be next Wednesday, does that actually enhance the total precipitation before kicking the system out, kicking it out here? That's what I want to know. By next Wednesday, what does that look like? So as we play it forward, we see it will get cold enough on the backside to be bringing some Great Lakes snow by next Thursday, Friday, and there comes system number 4 into the West Coast, all born off of this guy right here. Now, looking at all of that in sequence, let's now have a look at what the models are saying in terms of total precip. I'm going to add up the European first. We're just going to play this out a week, and we'll do some comparison here. So that's 1 week of total precipitation, and now you know how desperate this region is for some of this moisture. The GFS, let's do the same thing. Just play it out a week. And there we go. So you can eyeball it like this for some of the differences. The models are in much better agreement than they were earlier this week. But then I always like to just show you the comparison. So remember last time how wet the GFS was here and how wet the European was on the backside? Well, we got a bit more of a mix here. The GFS one has one notable area that it's much wetter, and that would be New England. So keep an eye on that. On the snowy side of it, I was already playing around with this before we started recording. But here you go. This is through, let's start you there. This is Saturday evening, Sunday morning, midday, and afternoon. Let's play now to Christmas morning, midday on the 25th, getting to the evening hours, And then let's just go ahead and watch this play out all the way to day 7. So you notice now that while there will be snow back here where the models have been pretty consistently putting it, they've now shifted the heaviest snow band farther to the east. Sorry about that. So we're just trying to assess what this system is capable of doing, and we better compare it to the GFS. And as we play that out, I do see some similarities overall. So watch. European, GFS. European, GFS. Now, what happens with this when it gets to New England, I cannot tell you just yet. I have to wait to see how the system evolves early next week before we get something going there. And when do we start to bring in better snows to the west? I mean, the Sierra Nevada, we talked about this yesterday. We're about 15 to 20% of our average snow. We need a whole lot more than this. But adding quite a bit into the Rockies here, the Central Rockies is going to be key. All right, one other thing. I mentioned the ice. When does it get there? I want you to watch right into this area. There we go, 6 a.m. on Christmas, midday, getting into the evening. Now watch. I think it's going to be the overnight hours on Christmas to the day after that we start to see the risk of getting some ice on the northern side of this. So let's keep an eye on that. How about some probability maps? Now, I'll just use the European ensemble. It's got more ensemble members in it, and I think there's better alignment now than there was earlier this week. So through Christmas Day, this is who has the best chance at getting an inch. So what has changed? It's primarily changed right in this area. We've seen this drop off and increase into this region. Here's the best chances at 3 inches. Whoops, darn it, I always get a new model run. That's what daylight saving time does to me. Let's take it out. Let's just go out to 10 days now. That's the chance of getting 3 inches out of this. And if you're looking for the heaviest stuff, it looks like right now the models are trying to give us the highest probabilities of having the heaviest snows here. Now this, just listen, this is going to change. We're still 4 days out to see what that heaviest snow band is going to be. I cannot pin it down just yet, but we'll watch for that carefully. I do know this. I feel pretty confident about this map, looking at the chance of getting an inch of liquid out of all of this in the next 10 days. The whole fact that the system has slowed down has kept it pretty consistent with the wettest conditions here, but this will move east, bringing rain with it as well. Okay, from there, I want to go back to this view, top-down jet stream pattern, right? Now, because the Pacific jet is extending like it is very common when the Pacific jet extends for it to break apart across North America. We've watched this evolve, I feel like, for a month now. And we know that this deep trough in Alaska gets support out of a Pacific jet extension. And the split that you see here, ends up giving us northwest flow through Canada and a strong subtropical jet stream. I did get asked the other day why I don't often talk about all of the different teleconnections that we see out of this, like the EPO, the WPO, because ultimately those are all descriptors of the jet stream pattern and the surface pressure pattern. So I'd rather just look at it all at one piece than break those apart. But that's not a criticism of anybody that does. But what I do want to say here about this pattern, this is most critical, is once we get here toward the end of the year, full jet extension, risk will be in California to be wet, risk will be for systems to roll up the East Coast on the northern side of that jet extension, but split here means nada. Okay, well, not nada, but just less, is that when we begin the new year, the jet starts to retract. And that makes a ton of sense given what the MJO is up to. Now, if the jet retracts, this allows the ridge that's been here to start to move. And if it moves farther and farther to the west and gets over Alaska, we get into January with this guy. And do you see the direction of that flow? Yeah. Look at the trough here. Look at the fact that we're kind of shoving that northwest flow back. This could indicate a really good and active start to the new year. Now, I could be really speculative and say what I think the temperatures are going to do and what the precipitation is going to do, but it would just be that. What I'm telling you is I think if that jet does retract, and there is evidence that it's going to, that first, I don't know, let's call it January 3rd through the 10th, it's going to be, I think it could be really fun for the U.S. I think we could really start to see a much more active, more winter-like pattern. Now, do we get the mild air out of the place? We have to answer that question. So first of all, expect these maps to change. This is week 2, excuse me. So, looking at the 29th through the 4th, you get beyond about the 3rd and 4th, this is all going to look much different because of that change in the jet stream pattern. But as it is, most of week 2 is the finish of December and the beginning of January. I think everything gets going right after that. Now, on the temperature side of it, before I give you that new long range I've been thinking about, here's today's highs compared to average. I mean, an absolutely warm day here out ahead of this system. 61 in northern Nebraska. Amazing. Then we get out here to Saturday, another mild one. Sunday, this is the one where I'm saying I think we might, even though it'll be mild, to get the temperatures this warm, it'll all depend on cloud cover and rain. And then we get into Monday, that all shoves east, gets out here on Tuesday. But you'll notice that even though the pattern brings in a shot at cooler air behind it, we just don't have the source of the really, really cold air just yet. But the newest European model does reflect that change in the subtropical jet by day 5 through 10. So you start to see the cooler conditions showing up here. Now, why is it still mild? Well, we're watching that ridge retreat. It's got to get back to Alaska before there's any significant change. We just play this out there day 10 through 15. And see the warm air going that way? That could be the beginning of some change. Now, told you, these 5 or 6 slides right here are the ones I really want to focus on because this is where I think the pattern's going. I think right now, El Nino in the background, we've talked about it's plateaued. We expect it to stay where it is for a while. I think what's going to happen is that the most important global teleconnection right now is in the MJO movement, okay? So the MJO has come out and is expected to get out in phase 1. The new long-range forecast, well, let's look at the 15-day, sweeping it through the Indian Ocean. The new long-range from the European says, well, don't just do that, but keep it sweeping through all the way back around. Now, sometimes the European model just craps out and dives everything back into null space or just leaves it in one spot. This is a robust signal of movement. And if it does that, that is kind of the mover and shaker in the atmosphere that's going to reinvigorate the Pacific jet stream to change its position and maybe give us more of a polar component to it. If we do at the same time displace the deep trough that's been over Alaska with this just means expect change. Expect January to not look like December. And here's why. Man, if we look right now at what the effect of MJO phase 1 is, where we are currently, We've got this, right? Oh, look at the subtropical trough coming in underneath, the ridging that keeps sitting in the midsection of the country, giving us that northwest flow. And where's the deepest cold air? Alaska, and then there's the jet extension. I could explain away the current pattern with MJO phase 1 very easily. But watch what happens if we get into phase 2. And there might be a little bit of a lag on it because we have to let the Pacific jet come back. It needs to retract. But if MJO phase 2 gets there, this will be the big thing to watch. I've talked about it all week. This could be the signal in January, not the very, very beginning, but after we get past the 2nd, 3rd, 4th, that we could go into a stormier time period. That could be the culprit, that trough of low pressure right there. I love it that there's a ridge over Nova Scotia as well, because that could help make the systems make the hard turn up the East Coast. And why I like it so much is this is a pattern that brings in moisture. Now, we don't like that for travel. We don't like that for comfort, but we need this for agriculture. Okay, what if it continues the progression, phase 2 to phase 3? Well, if that occurs, that all moves by the time we get into the middle of January here and starts to just crank systems or increase the risk of systems east. But following it, look, we build ridging back into Canada, which likely means in this particular scenario that we get a kind of a week off or so for much of the rest of the country while the east just gets ripped up by these systems. But then if we get into phase 4, this could mean another mild time period for much of the country while the west starts to re-engage with the pattern once again. I think this MJO progression, 1, 2, 3, 4, could define what the month of January looks like. And I'm going to be honest, even though we see it in the European model doing this, the European model forecast solution doesn't reflect it. and neither does our newest update from the government. So they're projecting January to look something like this. And I have a feeling, and I know they're wrestling with this as well. We all are. Every forecaster is. I have a feeling that they'll watch the weekend model progression and next week want to be making some adjustments to this. And they usually do one more adjustment on it by the end of the year. I'll be anxious to see what that looks like. But I bet you their confidence in this forecast is low. Mine would be. Next, they also updated to reflect what we've been talking about for a while, their January, February, March outlook. And we're going to cover this again in a few moments. What I think is most critical, though, is this. If you look at their latest seasonal drought outlook, they've changed this considerably, keeping this drought persisting in these large areas here where there had been better evidence of improvement. Now, I think the primary reason for that, okay, by the way, I don't want to leave this out, they have now really changed their outlook for the Northwest. But the primary reason for this has largely been because the newest suite of longer range models has tried to keep, I put it in a dashed box or oval, the drier areas. They've tried to keep this drier, not only in the NMME, but here in the ECMWF, and it's even kind of here in the IRI multi-model probability forecast. Now, what I'm going to tell you is most of what you see here is predicated on typical El Nino behavior as the dominant physical driver in these forecasts. And I think El Nino is at a peak and beginning to fade. The MJO movement on top of this El Nino will be our strongest tropical teleconnection. And it could very easily disrupt these forecasts. So I want you to look at this and take them with a grain of salt, understanding that they will likely change considerably with time. So as a quick review, this is the progression of the trough ridge pattern I'm expecting in January. This is now through the beginning of January. This is likely that Jan 4 to Jan 15 outlook. Mid-January shifts east, more mild air possibly returns at some point, and then we get into a reset, starting in the west and progressing east once again. January is going to be a month of volatility, and there is some evidence it's going to lead into a cold February. I know you're all going, yeah, Eric, it's February, it's cold in North America. No. I think we're going to move into a colder than average February. By how much is yet to be determined, but I think colder than average is on tap for what's happening this February. Okay, from here, I want to show you an animation. This is about Brazil. Brazil is this massive wild card that I have yet to fully pin down. In the last week, watch the convection here. So this is satellite-derived precipitation. And you're going to notice as we get to the 19th, sorry about the blue, but there we go, the 20th and 21st, you see the convection building back in. I've seen it on visible satellite data as well. I mean, you can tell, look, there was convection yesterday afternoon. This crosses the equator about 1:30, so you can see the convection in this area. And by the way, there's the sun glint right on the Tropic of Capricorn. We talked about that yesterday. So there have been some storms hitting this area. But we cannot ignore the fact that since October 1st, we have significant portions of Brazil that are showing up with the driest data since 1979. And I had to go back to 1942 before I found in this region a drier start to a growing season. But we looked yesterday and saw that the NDVI data was beginning to show improvement. We've not yet heard from a lot of growers down here saying that this crop is a complete disaster. It's a massive wild card for me. If I just blindly trusted the data, I would say there's a huge, multi-state problem down here with flooding in southern Brazil, which was bad earlier in the season. I'd say Argentina's looking at much, much better conditions than it did a year ago, and we covered that recently this week as well. Now, comparing that to another data set, this is the CHIRPS data set. Same time, well, almost the same time, but October 16th to December 15th. And we just see expansive drought in these areas. And these are several of our key growing areas. Could things in the middle, like Mato Grosso do Sul, Sao Paulo, Paraná, down in Santa Catarina, and Rio Grande do Sul, could they be in such good conditions that we can outdo some of this? Could Argentina's larger crop, last year crop production was cut in half, could it be making up for this? I don't know. But I think there's a problem that is sitting here that could really rear its head if between now and a couple of days after the start of the new year, we do not see the rains that are currently forecast. So what are we going to talk about? We're going to look at the probability of getting 2 inches of rain in the next 10 days. And those probabilities are still sitting here in the 70 to 90% range. 2 inches of rain in 10 days would be almost to the climatological average. It's in fact right about the climatological average. If this verifies, this would be absolutely huge. What does the GFS say? Well, it's got lower probabilities. It's been the drier of the two models for a long time. The European, has been too wet. The GFS has been too dry. Does the truth lie somewhere in the middle? That's the big question that we have to ask. But this will be, I have a feeling, the manifestation of the rains over the next 2 weeks will be the make or break point for this crop. I think if they do not manifest themselves, then my whole outlook going forward, even with the MJO moving around like it is, would say that persistence wins the day in Brazil. Drought begets drought, right? If it breaks, I have a feeling it breaks for the really wet. Now, I don't think that any long-range model captures that, and I want to show you this. This is the newest European extended forecast. We're going to do a sliding 1 week window from now all the way through January. Now, look at what the models do. They just keep trying to bring back that rain. Look at this. This would be the first week of January, and this would be the second week of January. Let's get into the third week of January. There's a drier time period, but then watch. Fourth week of January, it comes back. Now, if you did make it really dry, let's just imagine, let's paint a scenario here. Let's imagine that the models are all too wet. And then at the end of January, it comes on super wet. That would be the worst case scenario, because we'd hit the crop with significant drought and heat again, and then it would get hit late with heavy rains inhibiting harvest. That would be the worst case scenario. So what we need to watch is, we'll watch to pay attention to see if we do actually hit these rainfall totals, what it does to the data, what it does to the NDVI values. And I think at the beginning of the year, this is going to cause, I think, some reaction in a lot of different ways. So we'll watch it, and I'll report back to you when I next pick up with a video. Have a great rest of this year. Merry Christmas to all of you, and I hope you all have a good start to 2024. Thanks.